Hello guys, so we are going to continue a discussion with respect to deep learning. In this particular video, we are going to understand about something called as chain rule of derivatives. A super important topic because this is something related to the weight updation formula itself. So till now, already you have seen, we have discussed about the weight updation formula. We know the formula over here. The generic formula is basically written, right? So if I probably talk about the weight updation formula, again, let me write it down over here. W new is equal to W old minus learning rate of derivative of loss with respect to derivative of W old. So this is the entire formula that is basically used for the weight updation. Now let's go ahead and understand what exactly chain rule is. Okay. So as you can see this, right, this is my input layer. This is my hidden layer where I have just one neuron. And this is my output layer. So let me just write it down so that you don't get confused. This is my HL1 and this is my output layer. And finally I get my output. And then we calculate the loss function and then we do this was initially the forward propagation and then we do the backward propagation. In backward propagation, we update the weight. Now let's imagine if I really want to update W4, right? And obviously see guys, in the forward propagation, after the processing that happens, let's say that this input is O11 and this input is O21, or I can also write it as O1 output and O2 output. So basically after doing all the processing and applying the activation function, I'm getting the O1 output after this neuron and this is basically my O2 output after this neuron. Okay. Now if I really want to update W4, then the formula is quite simple. What I write, so it is nothing but W4 new is equal to W4 old minus learning rate of derivative of loss with respect to derivative of W4 old, right? And obviously you know that if I take this term, right? And if I expand it, how will this expansion look like? Now see this guys, this is super important. So if I just take this term and basically write derivative of loss with respect to derivative of W4 old, it is nothing but derivative of loss. See, loss is entirely dependent on O2, right? So I will be writing derivative of loss with respect to derivative of O2, and O2 is dependent on W4, right? So here we can split this equation of derivative of O2 with respect to derivative of W4. So once we write like this, here you'll be able to see that the same derivative has been expanded in this way. And at the end of the day, if I cut this two, right? If I cancel out this two, it is going to remain the same thing, right? Derivative of W4 old. So this splitting of this derivative is basically called as chain rule. Okay. Chain rule of derivatives. Super important. Okay. And that is how we will be able to compute each and every component with respect to finding the updated weights, right? So whatever value we'll be getting, whether it is a positive or negative value, then we will multiply with our learning rate and then we'll updating the W4 weights. Now let's go ahead with respect to W4, it is fine, but let's go ahead and try to update W1 or W2 or W3. Now with respect to W1, what my formula will be? It will be nothing but W1 new is equal to W1 old minus learning rate of derivative of loss with respect to derivative of W1 old. Now let's consider this. And let's go back and let's expand this with the help of this chain rule. Now here you can see the output from this neuron is O1, right? So this W1, O1 is dependent on W1, right? This O2 is dependent on W4. And in short, you'll also be able to see this O2 is also dependent on O1. So how we can actually expand this with the help of chain rule? Now this is super important to understand. You can pause the video, you can just try it by yourself. Anyhow, I'm just going to show you. So let's go ahead and let's show you this particular method. So here, what I can do is that I will write derivative of loss with respect to derivative of W1 old is nothing but here, first of all, derivative of loss is dependent on O2. So here you can find out this loss is dependent on O2. Then O2 is dependent on W4, right? Then W4 is dependent on O1 and then O1 is dependent on W1. So I hope you are able to understand this, what we are basically doing with respect to updating this W1 and the other values, right? So here you can see that loss is dependent on O2. this W4 is basically getting combined with O1 and W4, right? So that is the reason O2 is dependent on O1 also, right? So here I can basically go ahead and write derivative of L with respect to derivative of O2 multiplied by derivative of O2 multiplied by derivative of O1. Sorry, divided by derivative of O1. Understand this. Loss is dependent on O2. O2 is dependent on O1 because O1 is getting multiplied by W4 and then an activation function is getting applied to get O2. And then this O1 is dependent on this one, right? So this is how it basically goes, right? So similarly, the chain rule will be like derivative of loss with respect to derivative of O2, multiplied by derivative of O2 with respect to derivative of O1, and finally we'll be having derivative of O1 multiplied by derivative of W1 old. So if you deduct all these things at the end of the day, I'm going to get this, right? So this is how a chain rule basically happens, okay? Now there are two assignments that I really want to give it to you. Just try it for updation of W2 new also and W3 new also, okay? Now, one more thing, let's say that this is another neural network. In this neural network, what all things are there? And this is also an assignment for you. But anyhow, I will give you the answer, okay? This is my input layer, okay? Just understand this. This is my hidden layer 1. This is my hidden layer 2. And this is my output layer, okay? Now here, first time I'm using two hidden layer. In the hidden layer 1, I have one neuron. In the hidden layer 2, I have two neurons. In the hidden layer 3, I have one. Basically, the output layer, I'm just having one. So that is basically nothing but a binary classification problem. So the assignment question is, how do you update W1 new? Okay, so this is W1. So here I need to find out this one. Okay. Now this is very important. Loss is dependent on O31. O31 is dependent on O21 also, O22 also. O22 is dependent on O12. O21 is dependent on O11. And these both are dependent on W1. So how do you think? Obviously, this equation is very simple, right? I will write W1 new is equal to W1 old multiplied by learning rate, derivative of loss with respect to derivative of W1 old, right? So this is the formula. But now the main thing is that I want you all to expand this equation according to the chain rule. Okay. So let's go ahead. You just try it by yourself and then I will show you. So this is nothing but derivative of loss with respect to derivative of W1 old. This is nothing but, first of all, I want to find out derivative of loss with respect to W1, right? So first, loss is dependent on O31. So I will go ahead and write it. Let's see this. Okay. So I will go ahead and write it. Derivative of loss with respect to derivative of O31. Okay. I'm just going to make this bracket. Now O31 is dependent on O21 also, O22 also. First of all, let's go with this side. Okay. So O31 is dependent on O21. So here I will write multiplied by derivative of O31 divided by derivative of O21 multiplied by derivative of O21 divided by derivative of O11. So here you have derivative of O21 divided by derivative of O11. Okay. And then finally you will be able to see derivative of O11 will be dependent on W1 old, right? So here I will write derivative of O11 divided by derivative of W1 old. Okay. So this is the first side, right? I hope you are able to understand this is the first side, but we did not still pass this, right? We went through this rule, right? From here to here we went and we went here to here and finally we updated this. But what about this? This part is also dependent, right? Here you can see O31 is also dependent on O22, O22 is also dependent on O11. So what I'm going to do, I'm just going to do an addition, and this addition will now have another layer which will say derivative of loss with respect to derivative of O31 plus derivative of O31 divided by, it should not be plus, it should be multiplied, because chain rule it says that derivative of O31 divided by derivative of O22. Why O22? Because this is O22 output, right? Right, O31 is nothing but O22 multiplied by W5 and then an activation function we specifically apply like sigmoid. Okay. And then you can also see that I will be writing derivative of O22 with respect to derivative of O12, I guess, right? So this is nothing but derivative of O12, and then O12 is directly dependent on W1. So finally, this is how my derivative of W1 old. So this is how my chain rule will look like with respect to the updation of derivative of loss with respect to derivative of W1. So if you really want to update this, this will entirely get converted to this equation. And that is how a chain rule actually works. A chain rule of derivative. I think you may have studied this in 12th standard and 11th, 12th standard, right? So this you will definitely be able to understand. Okay, so this is what is a chain rule of derivative, and this always happens with the help of, because see, at the end of the day, if I'm trying to find out derivative of loss with respect to 031, here we are just trying to find out the slope, right? And because of the optimizers, we'll be able to find out the slope efficiently, and that is how we get the entire values. Okay, so yes, this was it. I will see you all in the next video.